All right, today's lesson is about finding the surface area of three-dimensional objects using a net diagram. So what does that mean and what are we doing? Well, what it means is at the current moment, we don't have formulas to find surface area. So how can we use the area formulas that we know to find the surface area of a three-dimensional object? What's this shape called? It's like a cube. This is a cube. So a cube is a cube because the length, width, and height are all the same. That's what makes a cube a cube. This is different because it has a length, a width, and a height. A length, a width, and a height, which are all could be different. So it's like a cube, but it's not a cube. So what name does this have? Anyone know? It's a rectangular prism. Okay? This is a rectangular prism. And we will need to know these names, not necessarily today, but definitely when we do surface area with formulas, we'll need to know the names of these objects. This is a rectangular prism. Now, in order to find the surface area of this object, what we're going to do is we are going to basically deconstruct the box. If we were to take the box apart, we would get something that looks like this. How many sides is there on a rectangular prism before I folded it or unfolded it? How many faces are there? There's 6. If you look at the picture, there's a front and a corresponding back. There's a left, a right, a top, a bottom. There's 6 sides to it. And there's 6 pieces here. What shape is all 6 of these parts? Rectangles. One may be a square, but it's only a square if the length, width, and height are the same. Like if the length and the height are the same, then it'll be a square. But they're definitely rectangles. Okay? So what we're going to do is we're going to learn how to find the surface area by drawing net diagrams. So right now, we don't have formulas to find the surface area. So we don't need a fancy tool to do this. We can just kind of sketch this. So we're going to sketch kind of what I had there. I had like a big long strip thingamaroo, and I had something like this too. And then we're going to have an additional side like right here. So I want you to draw something like that on your paper, please. And then we're going to put some numbers on it and label it and then go from there. All right? Now, it totally depends on how you want to do this. What I'm going to do is I'm going to call this the bottom. And I'm going to say that if I folded this piece here, this would be the back. This would be the left side. This would be the right side. This would be the front. And this side here would be what? What would this last piece be?
Top.
The top. Very good, Wawatu. So now, it's the labeling of the sides, like calling them top, bottom, left, right, front, that matters, but it doesn't really matter. What really matters is the next part, because the next part is we are going to label the length, the width, and the height. We're going to label the length, the width, and the height. So I can see in the diagram here that the length is 16 centimeters. So just so that we can see that, that means that this is 16, this is 16, this is 16, this is 16, and this is 16. They're all 16. So that right there is 16 centimeters. Okay? Now, based on the picture we have above, I'm going to start right here. What would this be? What would this be right here?
9 centimeters.
How many?
9.
Be
Or no, 6.
6. Because if this is the bottom right here,
Okay.
the bottom is 16 by 6. That's right.
Okay.
Now, my diagram's not to scale, and yours does not need to be either. So that also means, if I'm going to use my highlighter here to highlight, this, 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 and this are all going to be 6 centimeters. And you don't have to put it on every single one necessarily, but you should put it on a few of them. Okay, so all of these are 6. Now my question to you is, what would this be and what would this be? These pieces are going to fold up, and what are they both going to be? 9, that's right. So they are both going to be 9. So that's 9, that's 9, that's 9, that's 9, 9, 9. So that's going to be 9 centimeters here. I'll put 9 centimeters there. I'll put 9 centimeters here as well. And yeah, that's good. So, okay. Now, here's my next question. What's this going to be right here? What's this going to be? 9, that's right. Because it's the front, and the front is 16 by 9. We already know this is 16, so that's got to be 9 as well. So this is going to be 9 centimeters right here. And last but not least, what's this right here?
9.
No.
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 6.
6. Because the top is going to be like the bottom. And the bottom, we already said, was 16 by 6. So this is 16 by 6. So you have, when we have these 6 parts, or the 6 sides, the top and the bottom are always the same. The front and the back are always the same. The left and the right are always the same. And that's always true for a rectangular prism, which is what this is. Now, we're going to find the area of each of these 6 parts. So let's do that. So, area of the back. We'll start at the top. The back is going to be what times what? And the length and width are what for the back? 16 times what? 9. 16 times 9 is 144. And if you need a calculator for that, that's just fine. Remember, calculators are okay. But if you can do it without a calculator, bonus. Now we're going to go the area to the of the left. So what are we multiplying for the area of the left? 6 and 9. 6 times 9 is 54. Then we're going to do the area of the bottom. What is the length and width of the bottom? 6 and 16. Multiply those together and you get 96. And then we go the area of the right. Let me ask you this. Which side is the right like? The left. We already found the area of the left. The area of the left is 54. So the area of the right is also 54. So we don't have to do it again. So you don't do it again if you don't need to, right? Then we'll go to the area of the front. Which side is the front like? The back. What's the area of the back?
144.
So the area of the front is also 144. Last but not least, we have the area of the top. The top is just like the
Bottom.
bottom. The area of the bottom was,
96.
so the area of the top is also 96. So we're going to add all those together. If my math is correct, feels like a Monday to me because I was in school yesterday, but I wasn't with you guys. I think you get 588, and it's centimeters squared. Can somebody tell me whether that's the correct answer? 588 when you add all those together? So the surface area of this rectangular prism is 588 centimeters squared, and that's how we do it. Okay? Okay? And we will move on then. Next page. This is a what? What shape is this? It looks like a pyramid. Yes. Pyramid looks like this. With a square in the bottom and 4, what shapes are these? Triangles. So our net diagram is going to be a square, and it's going to have 4 triangles coming out from the edges of the square. And what is the length of the square? 8 by 8. So that means that this is 8 centimeters. That's 8 centimeters. What's the height of the triangle? 9. 9. And these aren't, by the way, I made a boo-boo. It's not 8 centimeters. It's 8 meters. That's my mistake. I'm sorry about that. And the height is 9 meters. Now, we're going to find the area of the square. And the area of the square is what times what? 8 times 8, or 8 squared. And 8 squared, or 8 times 8, is 64. Now for a triangle, we haven't talked about area of a triangle yet today. Anyone remember the formula for area of a triangle? It's base times height divided by 2. So the base is what? What's the base? Base would be what? What's the base of the triangle? 8.
Okay. You want to wear this for the day?
No, I'm good. Thanks, though.
They say it's the best game of the year. You watch it?
Yeah, I did. It was
man.
good.
What a game.
What's the height?
That was random.
Be 9, and we're dividing by 2. So now we're just going to do 8 times 9 divided by 2. 8 times 9, again, if you need a calculator, it's perfectly fine, is 72. You divide that by 2, and you get 36. Now, how many triangles are there? 4. So to find the surface area, what we're going to do is we're going to go 36 times 4, and we get what? We're multiplying it by 4 because there's 4 triangles. What's 36 times 4?
84.
Nice try, not quite. 144. And then what we'll do is we'll add the 64 with the 144. But I'll do it with my pen and not my highlighter. 64 plus 144 is 208 square meters. And that's your final answer. So you find the area of his triangle, and you multiply it by 4 because there's 4 triangles. And you add it to the area of the square, and that gives you the surface area of the pyramid. Okay? So that's how we do that. Final example, how do we do this? What shape is this? It's a cylinder. The cylinder looks like this. So, if we want to find the surface area of a cylinder, what we have to do is we have to ask ourselves, what shapes make a cylinder? Circle and rectangle. That's correct. The example that I always think of when I think about this is if you have a can of soup. You know, you buy a can of soup, and what you can do is you can peel the label off. If you peel the label off carefully, you do get a rectangle. So you get a rectangle, and you get 2 circles. Okay? So the circle part is fairly straightforward. We get circle, and in this case, the diagram gives us the diameter. The diameter is 15 meters. So the radius is going to be half of that. It's going to be 7.5 meters. The rectangle is a little trickier because the height of the can or cylinder is 20 meters, and that's clearly labeled. But the question and the tricky part of this is, what is the length? How do we find the length of the rectangle? Either pi times diameter or 2 times pi times radius. And that's going to give us, we need to do that to find the length of the rectangle. So the radius is 7.5. We already said that. So now we got to take our calculator and go 2 times pi times 7.5. And that gives us 47.12 meters. That's the length of the rectangle. Okay? And we're going to use that to help us find the surface area. So our surface area is going to be made up of the area of the circles plus the area of the rectangle. Now, I did say area of circles because there's 2 circles. 2 circles means that we're going to multiply the area of one circle, which is pi r squared, by 2 because there's 2 circles. And we know area of a rectangle is length times width. What's the radius of those circles again? 7.5. Yippers. So 2 times pi times 7.5 squared plus the length, we just found it was 47.12, and we're going to multiply by 20. And now what we're going to do is using a calculator, and we can use a calculator on our phone or a standalone calculator. We're going to figure out what both those are. 7.5 squared. Order of operations, you do exponents first. 7.5 squared is 56.25. And then we're going to multiply that by 2 and then by pi. So multiply it by 2 and then pi. And we get 353.43. And then we're going to multiply 20 by 47.12. And that's going to give me 942.4. I think.
Yeah, I got that.
Yep. And if we add that to the 353 number, then we get 1,295.86, and the units are meters squared. And that's how you do surface area when we don't have formulas. We don't have, what's that? It's 942.4. And then where, is that what you're asking about, Wawatu? Good. And then the answer is 1,295.86 meters squared. So that is how you find surface area without formulas. Today we're going to learn all the formulas. But, tomorrow we're going to learn all the formulas. Today we're not. We're going to have some practice on this stuff. Okay? And, yeah.